Okay, in this video, we're going to look at solving quadratics by completing the square. So when we complete the square, that's a method of solving quadratics, and it's much more powerful than factoring. Now, factoring is really important, don't get me wrong. However, doing it this way is going to allow us to pretty much solve any type of quadratic that we want. So for example, if we looked at this one here, x squared plus 10x minus 21 equals 0, you might have a hard time finding two factors of negative 21 whose sum is positive 10, right? The only factors of 21 that I can think of is 1 and 21 and 3 and 7. Now, you might be tempted to say, oh yeah, it's got to be 3 and 7. Keep in mind, this is negative 21. So one of those has to be negative, the other one has to be positive. So even if I had like negative 3 and positive 7, when I add those together, I get plus 4. And when I have positive 3 and negative 7, when I add those together, I get negative 4. So it's not that. So you may be tempted just to say, oh, well, you know what? We can't factor this, so this has no solution. Well, I'm afraid that's not the case. Let's head over to Desmos and take a look at the graph. Okay, so here's the graph of x squared plus 10x minus 21. Now, you'll notice that just like most other quadratics that we've looked at so far, we have two x-intercepts. Remember that those x-intercepts correspond to a solution to this equation. Just like the other quadratics that we've looked at so far, there are two solutions to this. The way we find those solutions is by completing the square. And let me show you how to do that. I'm going to walk you through each step. The first thing that I'm going to do is I'm going to sort of ignore this minus 21. So what I'm going to do is I'm going to just put brackets around here and think of this as my own little expression. And what I want to do is turn the portion that's in the green brackets into a perfect square. I made a little video on perfect squares previously, so if you haven't seen that yet, check it out. It's only a couple minutes long. So to turn this into a perfect square, what I have to do is, well, I'll keep everything else the same. I'll have x squared plus 10x. But remember that this term right here, this one I'm going to have to divide by 2 and then square it. When I do that, well, I'll have 5 squared. And what I'm going to do is I'm just going to add that. 5 squared is 25, pardon me. So I'll have 25, and I'll close those brackets. Now I have to make sure that I end up subtracting that back out. I can't just add 25 to an expression, otherwise I would be completely changing the expression. So I'm going to subtract 25 over here, and then I also have to include that minus 21, and this is all still equal to 0. So far I haven't changed the equation. I've really just added 25 and subtracted 25 and put some stuff in brackets. Nothing, fundamental about this equation is different. It's still the same equation. So now the portion in the green brackets, this is a perfect square because the middle term is, if I divide that by 2 and then square it, is the third term. So what I can say is that this is now x plus 5 squared. And on the outside, I have that this is, minus 25 minus 21 is minus 46. And this is all still equal to 0. Perfect. I'm getting a little bit closer. You might also notice that this is in vertex form. Not only is completing the square useful for converting this into vertex form, we can also use completing the square for solving the quadratics too. So this is a very important skill. Next thing I'm going to do is I'm going to move that 46 to the other side of the equation. So essentially adding 46 to both sides, and I'll have x plus 5 squared is equal to positive 46. Next up, I am going to introduce a square root symbol. Now, something to point out about a square root symbol is that when you introduce a square root symbol, then you have to include a plus and minus. Now I have on the left x plus 5 squared, and I've taken the square root of it. Well, that's easy to do. These just cancel out, so the square root cancels with the square, and I'm left with x plus 5 is equal to plus or minus the square root of 46. And finally, what I'm left with is x is equal to negative 5 plus or minus the square root of 46. And if we want, we can turn that into a decimal form. So in decimals, we'll get that x is equal to, well, let's first think of the plus. So x would be negative 5 plus the square root of 46, which is equal to negative 5 plus 6.782, and I've rounded, so I'm going to put a little dot on top, and this is equal to 1.782. That's where that 1.782 came from. Now, the other option is this minus, so I'll do this in blue. So the other option could be that x is equal to negative 5 minus the square root of 46, which is equal to, well, I already figured out that the square root of 46 is 6.782, so 6.782, negative 5 minus negative 6.782 is negative 11.782. And those are the numbers that we had over here. Negative 11.782 and positive 1.782. Okay, let's try to solve this equation. We've got negative 2x squared equals 3x minus 7. The first thing that I want to do, and this is the first thing you're going to want to do with any quadratic equation, is to gather all the terms onto one side. So let's gather them all to the left. So we'll have negative 2x squared minus 3x plus 7 all equals 0. Now what I'm going to do is I'm going to divide both sides of the equation by this negative 2. The reason I do that is so that my leading coefficient, that's the coefficient in front of x squared, is 1. And that'll make our life a lot easier. That said, we will have to work with some fractions, so we do need to be familiar with fractions, but we wouldn't be able to complete the square without doing this step first. So let's go ahead and do that. I've got negative 2. I'm going to divide both sides by negative 2, divide by negative 2, and what I'm left with is, well, I'll have x squared, because negative 2 divided by negative 2 is just 1. Then I'll have plus 3 over 2x, and I'll have minus 7 over 2, and that's all equal to 0, because 0 divided by negative 2 is still just 0. Now it's time to complete the square. So I'm going to throw some brackets around here, and I'm going to just work inside those brackets. So what I want to do is I want to take this term, 3 over 2, and divide it by 2, and then square it. So in other words, I'll have, and I'm going to write this over here so it's not in my way. So let's put this over here. So this is equal to, well, 3 over 4 squared, and that's equal to 9 over 16. Okay, so I'm going to add and subtract 9 over 16. So I'll get that this is x squared plus 3 over 2x plus 9 over 16, and then outside the brackets I'll write minus 9 over 16 minus 7 over 2. That's all equal to 0. And now I can go ahead and complete the square. So this over here is going to be x plus 3 over 4 squared. And now I have to clean up whatever's left. So I've got 9 over 16, or sorry, negative 9 over 16 minus 7 over 2. Well, what I'll do is I'm going to multiply both of these by 8. So I've got times 8 times 8. That gives me a common denominator of 16. And I'll just write my denominator of 16. I'll have negative 9 minus 56, which is negative 65. So I've got 65 over here. I've got negative 65 over 16. And that's all equal to 0. Now I'm going to move that negative 65 over 16 over to the other side. And I'll have x plus 3 over 4 squared equals 65 over 16. I'm going to have to move over here. And now I'll take the square root of both sides. I'll do that on this side here. We've got the square root. And remember, I have to include that plus or minus symbol. And that gives me x plus 3 over 4 equals plus or minus the square root of 65 over 16. Now I'm going to just solve for x, and I'll have that x is equal to negative 3 over 4 plus or minus the square root of 65 over 16. But keep in mind, I'll just write this as an aside, the square root of 65 over 16, that's equal to the square root of 65 over the square root of 16, which is actually equal to the square root of 65 over 4, because the square root of 16 is 4. So let's convert that. I've got x equals negative 3 over 4 plus or minus the square root of 65 over 4. And now these are common denominators, so I can just write that this is equal to negative 3 plus or minus the square root of 65 all over 4.